use and exceptional detail capture. Advanced hybrid alignment paired with ultra-large scanning area simplifies operation and doubles efficiency. How fast is it? Scanning speed up to 70 frames per second under laser mode. A perfect blend of high performance and efficiency. 17 blue lasers crosses have you covered, bringing unparalleled detail to life. Need accurate color reproduction? Your phone and best texture function deliver exactly that. Immerse yourself in a vibrant 3D world. 17 blue lasers. In any environment, small components or large vehicles, MT adapts with ease. Indoors or outdoors, MT handles it all. From objects to humans, switch without a hitch. With multi-line laser modes, MT conquers black and reflective surfaces. MT unlocks endless possibilities in 3D exploration. .3DeVOK MT redefines what efficiency really means. Multi-line lasers and target-free scanning ensure fast data capture. It offers both ease of use and exceptional detail capture. Advanced hybrid alignment paired with ultra-large scanning area simplifies operation and doubles efficiency. How fast is it? Scanning speed up to 70 frames per second under laser mode. A perfect blend of high performance and efficiency. 17 blue lasers crosses have you covered, bringing unparalleled detail to life. Need accurate color reproduction? Your phone and best texture function deliver exactly that. Immerse yourself in a vibrant 3D world. MT's reliability lets it perform smoothly in any environment, small components or large vehicles. MT adapts with ease. Indoors or outdoors, MT handles it all. From objects to humans, switch without a hitch. With multi-line laser modes, MT conquers black and reflective surfaces. MT unlocks endless possibilities in 3D exploration. .3DeVOK MT redefines what efficiency really means. Multi-line lasers and target-free scanning ensure fast data capture. It offers both ease of use and exceptional detail capture. Advanced hybrid alignment paired with ultra-large scanning area simplifies operation and doubles efficiency. How fast is it? Scanning speed up to 70 frames per second under laser mode. A perfect blend of high performance and efficiency. 17 blue lasers crosses have you covered, bringing unparalleled detail to life. Need accurate color reproduction? Your phone and best texture function deliver exactly that. Immerse yourself in a vibrant 3D world. reliability lets it perform smoothly in any environment, small components or large vehicles. MT adapts with ease. Indoors or outdoors, MT handles it all. From objects to humans, switch without a hitch. With multi-line laser modes, MT conquers black and reflective surfaces. MT unlocks endless possibilities in 3D exploration. .3DeVOK MT redefines what efficiency really means. Multi-line lasers and target-free scanning ensure fast data capture. It offers both ease of use and exceptional detail capture. Advanced hybrid alignment paired with ultra-large scanning area simplifies operation and doubles efficiency. How fast is it? Scanning speed up to 70 frames per second under laser mode. A perfect blend of high performance and efficiency. 17 blue lasers crosses have you covered, bringing unparalleled detail to life. Need accurate color reproduction? Your phone and best texture function deliver exactly that. Immerse yourself in a vibrant 3D world. MT's reliability lets it perform smoothly in any environment, small components or large vehicles. MT adapts with ease. Indoors or outdoors, MT handles it all. From objects to humans, switch without a hitch. With multi-line laser modes, MT conquers black and reflective surfaces. MT unlocks endless possibilities in 3D exploration.
这个手机照不到，它只能照到这里。一会儿你先说。
可以。Okay. Hello everyone.
Hello everyone.
Yeah, we are 3DeVOK team. Today we will do a whole procedure of the Scan-to-CAD live stream. And Richard will be today's engineer for the whole process. And I will read the comments and also do the interaction with you and also explain and present the whole scanning process. And this is Jennifer. She will in charge of the whole process, and including the recording and the other live stream control.
Yes, nice to meet you, our fans in LinkedIn and YouTube. And if you have any question, please type your questions on the comment section. And welcome to Reason. We will answer you in real time. Thanks.
Yes, and if you have any doubts and questions, please text to us, and I will give you the answer at the Q&A section or do the real-time answer. So let's get started. I prepared the industrial part today, and I will do the reverse engineering based on this industrial part. But first of all, we want to produce a 3D mesh model. So I will let my colleague Richard to do this scanning.
Yeah, I'm Richard. I will demonstrate for you today. We are going to show you how to scan the part and reverse repaired parts use QUICKSURFACE.
Yes, so today we will do the scanning with a 3DeVOK MT scanner. And then we will export the model using the 3DeVOK Studio software, and then we will do the reverse engineering with the QUICKSURFACE software. So let's get started. First of all, we need to prepare a turnable that is full of markers because we need to finish it at the background plane. And then we need to put this industrial part on the turnable. Make sure all the things are stable during the scanning because we need to make sure all the position of the markers are fixed during the scanning. So we can choose the laser scan in our 3DeVOK Studio software and then choose the blue laser and the marker alignment. Before the scanning, we have set the scanning settings about the resolution. We will use the 0.5 resolution to scan this industrial part. First of all, we need to scan all the markers on the industrial part and on the turnable. Make sure all the angles are captured because we need to make all the position precise.
We will scan all data. Okay, the data will be good.
Okay, so all the position of the markers are captured. So click the Finish button. We can finish the calculation of each position of the markers. And then we can left-click and to select several markers to create a virtual background plane.
Yeah.
That will be useful for blocking the excessive data, including the turnable. With the blue laser marker alignment, we can scan the data at a 70 FPS as the highest. Slowly turn the turnable so that we can fully capture the data. Actually, we have a function called a color map. The color map function will be useful for us to observe the data quality. So you can see there are several colors on the object with the with the green, yellow, and the red color. So when you are turning the whole object green, it means that the data is enough under that current resolution, which means 0.5 resolution is enough for us to process the point cloud data as well as the mesh data.
Okay, finished.
Yes, we have fully captured the data, and then we will finish to end the scanning process. Then we turn to the point cloud interface. At this step, we need to save the point cloud project. And also, we can proceed the data to remove some unnecessary part, including the isolated point and the disconnected components. At this step, we can save the point cloud project so that we can do the merging of the both parts. Since we are only scanning the top part, so we need a bottom part data, and then we can combine the data with the common markers on the part. Yeah, we saved the point cloud project. Since we have prepared the bottom part of this industrial part, and today we're gonna show you the real scanning of a surface. So I will definitely show you the merging of those industrial parts. And we will use the marker stitching function. Because we have done the bottom part, so actually we have two types of the APJ format project file. And clicking this function to import the two APJ file so that the software can recognize all the marker information. At this step, we need to find whether there are the same markers on the object. And then we need to choose at least 3 sets of the common markers so that the data can be merged and stitched together. This will be a very efficient way for us to scan the complete model. With this method, we can stitch the data at a very efficient way. Click the Apply, and then you can see a complete point cloud project is completed. To repeat the previous operations, to delete some noise data, to make the surface more smooth. Okay, so, and then we will do the wrapping, which can produce the mesh data. Okay, mesh data. At this step, this will be a conversion from the point cloud project to the mesh data. So this will be our material today for the reverse engineering. And actually, we can do some operations to make our model more smooth or to fix some surfaces. So like the filling the holes or do other operations. Use the auto fill holes. We can actually fill some very tiny holes on the object. So this will be today's mesh model for the reverse engineering. This is a relatively complete model. So the next step, we need to do the reverse engineering. Please wait a minute. Okay, after we are getting the real mesh model, we can click the jump to function to directly jump from the 3DeVOK scanning software to the QUICKSURFACE, which is the today's reverse engineering software. We have created a direct connection between the two software. The jump to function and click the QUICKSURFACE. And then our PC will automatically launch the QUICKSURFACE software and to import the STL model.
Sorry, there is something wrong in our screen.
Yes, please wait a minute. We are adjusting the screen sharing. If you are having some questions about the scanning just now, you can also type it in the checking box and let us see.
Okay.
Okay.
Yes, we want to show the direct jumping again, so that you can see the actual jumping of the 3DeVOK software to the QUICKSURFACE. So actually, you can see here is the jump to function in the QUICKSURFACE, and just one click, with one click, we can directly to import this model into the QUICKSURFACE software.
Okay, I will be doing.
So it's a very efficient way. So you can see this STL model is imported in the reverse engineering file. So the first step, we can edit the scanning data. But in the QUICKSURFACE software, we can do the simple processing of the model surface, like smoothing and remove some outliers. And since we have done it in the 3DeVOK scanning software, so to remove some unnecessary data, so we will directly start from the reverse engineering. So here I will explain the meanings of reverse engineering. The reverse engineering means we need to convert the scan data from the mesh to a CAD model. And the CAD model can be used for the actual production, including some laser cutting, 3D printing, or other industries and manufacturing. But the mesh data is not a parametric model, so it cannot be used for the real usage of the actual production. So it is more. So reverse engineering will be a bridge linking the scanning to the production, which is a very important way and a method for us to produce a very precise model. So here I will introduce the steps of the reverse engineering. First, we need to process the mesh model. You can process it with whatever software you want, like the scanning software itself, and also the reverse engineering software, like the QUICKSURFACE. And then after completing the model processing, we can do the reverse engineering in the software. The first step and the most important one is to do the coordinate, like the alignment, because we need to correct the real coordinate system of this model so that we have a right position for the following steps to do the production of this industrial part. So, and then we need to draw the 2D sketch and to extrude the features to create a solid, and then to combine separate the solid together to become a complete CAD model. This will be the complete process of reverse engineering. So here I will start from the extracting the primitives so that we can give a reference to do the coordinate alignment. Okay, so first of all, we need to extract the primitives. You need to observe the model and to find the geometric features that can help us to create a coordinate. First of all, we need to find the base. The base is the most important geometric feature of this industrial part that can help us to create the floor. And also, we can adjust the sensitivity that can help us to recognize the exact feature, the base. Then we can create a fitting plane. Imagine it as the floor of this coordinate system.
Great, understand.
Okay, so after the base is created, we can create other fitting planes, like the side, and also to find some elements on the mesh model that is helpful for us to create a coordinate system. So with this method, we have created 3 fitting elements, the 3 fitting planes that can help us to create to align the coordinate. So let's get started. Let's go to the following steps to do the alignment. Okay, so click in the coordinate alignment function. So you can see the software will prompt you to add some features into the software, which can help the software to calculate the exact position of this coordinate. So the primary feature as for this feature, we need to select the base, which will be the most important feature of this industrial part. So just find the fitting plane that we just created. Then you can see the coordinate will be is created at the same time. But it seems that the direction is wrong. You may find the z-axis will go downwards, or not in the correct direction. So here we need to click the apply button, and then to adjust the direction of each axis. To change the direction and also make the z-axis directing at the top.
Yeah, we need apply button.
Yeah, when we adjust the coordinate, we need to apply it again. Yeah. You can also click the flip button at the software to make the z-axis going up.
Yeah.
Okay, so the alignment of the coordinate system is finished. So you can see at the right upper side of this software, we can also check the coordinate. Make sure the industrial part is putting at the correct direction. And this direction will be maintained in other following software, like the 3D printing software or other like the manufacturing software as well. When we finish the coordinate alignment, the next step we need to do the 2D sketch. 2D sketch is helpful for us to find the projection at a certain view. Like you can see the outliers of this industrial part was projected. And also we can drag the reference plane to find which position can provide us with the most informative view. That means with all the geometric features projected at the software, we can draw the exact line, arcs, or other curves based on the 2D sketch.
Yeah, and create.
Click the create, so you can see the point cloud projection was created just now. And at this step, we are coming into the next part, that is to draw the exact outline and the cross section of this industrial part.
Yeah, we use shift.
Then you can circle the projection of the point cloud with the shift key and at the keyboard, and to create an exact light segment. That is a simulation of the project. And the software will automatically generate the most close geometric feature based on the 2D sketch. Just repeat repeat the previous steps. Use the shift key and left select with your mouse. The software can automatically find all the segments that you are choosing. We can also add some constraints on the line segment, like the vertical, and make it perpendicular or whatever. Yeah, this is helpful for us to go back to the original structure of the industrial part, because the industrial part was created very vertically and like a precise position.
Okay. And is control.
Press the control key and also select those two line segments. We can automatically create a cross line with the two line segments.
And control again.
Yeah, repeat and control key again. We can make the fillet and to automatically show the radius that was created with the software. But we can adjust the radius to a number that is close to the actual size of this industrial part. And we can also, to extend the like segment, make all the above steps, press the control key to continue to connect the rest of the like segments together. Observe the radius parameter and give them the more precise actual size. To unite the radius, because you know this will be a efficient way for us to produce a unite size of the exact industrial part. To make all the parameters getting close to the actual size.
And we need add the curve.
Okay, so for the this part, we need to draw a arc. Based on the 2 points and certain radius, we can give a limitation about this arc and make the make the end point of the arc be tangent to the line segment. And we can do the same thing at the right.
Tangent.
Yes, this will be the tangent way will be will produce the more natural actual structure. Slightly adjust the endpoints to make them more fit to the projection of the 2D sketch.
Okay.
Yes, and then we can observe the real part. At the bottom, at the top part, we need to create a complete model to extrude it like a solid. So we need to extend the like segment to the real part to cover the all top part, so that we can do extrusion.
And then.
Yes, we need to combine all the like segments and the arcs together to create a closed profile.
And you can cut it.
If we are producing the excessive like segment, we can trim the unnecessary data that we don't want.
Yeah, okay.
Yeah, click the OK. So you can see we actually draw the cross section of the top part. So you can see here we are giving the a closed curve of this industrial part. So at the next step, we can do the extrusion, which means based on this cross section, we can give some height or some parameters so that we can fit the real industrial part. And also we can press the control key to snap this face to the real object surface. And we can do the same thing at the other side. This aims to produce a precise size of this industrial part, and it's also the this is also a very useful function in the QUICKSURFACE. Okay, we have finished the modeling of the top part. So at the next step, we need to create the bottom part.
And use the sketch.
Yes, we need to do the 2D sketch again and repeat the previous steps we have done at the top part. Drag the reference plane again to observe whether all the geometric features are included in the cross section, because it will be projected.
Yeah, we'll create.
Yes, so you can observe this profile, and you can see there are few regular shapes like the arcs or something other geometric features. So we can draw the like segments first.
Yeah, use the shift.
Also using the shift key
Shift.
and select the line
And
the
hit
control key to join them together, and twice the control key to make the fillet. And you can design the size of the fillet radius. To unite them.
And you can use be vertical to the certain industrial part, and adjust the endpoints. Just repeat the steps we have done at the left side and set the parameters of the radius and unite them. now we can use
Yes, we have a free-form curve function here.
Okay.
Like if we are meeting some irregular curve and projection on the 2D sketch, we can draw the free-form curve and define the control point by yourself. The more the control point, the more precise of this free-form curve that you can stimulate. Just follow the projection of the 2D sketch to make our free-form curve more close to the actual point. Make it tangent. And you can make a very smooth switch between the line segments and the curve.
And this must be make tangent.
Yes, all the points joining the curve and the line segment should be make the tangent. And then we can produce a more natural shift at this turning point. After we creating this free-form curve, we can separately adjust some points of this curve because we need to make it close to the projection, the white line. Yeah, slightly move the control point on the curve to fit the projection to go back to the original shape. During this process, you need to make sure all the curves and the line segments are joined together from the beginning to the end, because this is very crucial for us to do the extrusion operation. If this whole profile and or the cross section are not joined together, and it is not a closed profile. We cannot extrude this free-form curve. So if you are encoding some problems during the extrusion, or if the software is proving you creating a solid is failed, you need to go back and check whether your curve is totally connected from the beginning to the end.
Let's see, it will be okay.
Okay, so we have created the bottom part profile, and then we will repeat the previous step to make the extrusion.
Okay. Now we use the sketch tool.
Yeah, this will be the second sketch for us to extrude. Yes, to drag those reference height or depth, and then to make it snap to the actual surface.
Okay, we need to use control.
Use the control key and snap it onto the actual model surface. Snap at the other side again.
It will be okay.
So this we finished the bottom part, but we observed the industrial part. There are 4 exact holes at the bottom. So you can also open the mesh and to observe it. We have 4 actual holes. So the final step we need to do is to dig the 4 holes. We need to extract the primitives at the holes again. But at this time, we need to choose the cylinder, which is the second button, to create a fitting cylinder. Yeah, to repeat the steps and make a 4 fitting cylinder.
Yeah, great.
Okay, so we need to extend the height of this cylinder so that it can go cross beyond the whole industrial part. That will be very useful for us to do the cutting. If the cylinder are not covered the whole surface of this holes, the cutting is incomplete. So you can also unite the radius of this cylinder, because you need to consider the real actual production of the industrial manufacturing. Definitely, we are not producing the 4 holes that with different radius, right? So we need to unite all the cylinders' radius.
Hello, I have one question. So if I want to get this CAD model, I only will cost half an hour or 1 hour. I can do this.
Sorry?
If I want to get this CAD model, and how much time I will cost?
Okay, I got a question from your side. She is asking how much time that we need to cost to make this reverse engineering. So with this the process that we are showing in the real-time live stream, we have created this model within half an hour. So this will be a very fast reverse engineering speed if you are familiar with it. Okay, so we need to dig the holes using the cut function to remove the cross section of those 4 cylinders and the bottom part, so that we can create a complete model based on the real object. Yeah, then we need to combine the solids together to combine the top and the bottom part, and then we can finish a real CAD solid, which will be used to the following manufacturing, just shifting to the mesh model to the CAD file. This will be today's live stream from the whole procedure, starting from the real scanning of this industrial part using the marker mode blue laser. And then we finish the mesh model, and with one click to export it from the scanning software to the QUICKSURFACE. Only one click. We can export this model. So in the QUICKSURFACE software, we have fully presented the process of creating the primitives, aligning the coordinate of this industrial part, and then to show the 2D sketch and draw the curve. So at the next step, we can show you the whole combination step. Okay, I noticed a question. How to create a parametric model? Okay, I got your point. So just now we have presented how to set the radius of the fillet, and also to define some parameters by myself. So I will repeat these steps by pressing the Control key and left-click the lasso. If the software can create the radius, create a fillet, you can import the parameter that you want. Am I making sense? This will be the whole process showing the live stream. If you are missing some important operation steps, we will also have a review. Like you can go back after this live stream. You can go back to the recording and to ensure the steps like the parametric steps.
这希望你详细的说一下。
Okay, so it seems that I'm not making sense just now. Okay, I'm not sure whether you are noticing the operation step that we have done just now, but you can see we are extracting the primitives and do the 2D sketch. And on the 2D sketch, we do the function like stimulating the real-time point cloud, and then to make the all the elements like the segments and the curve, and also the radius, also the fillet. And when we are creating the fillet, you can see the fillet has a approximate radius or the diameter based on the 2D sketch. If we want to adjust it, we can click in those box so that we can input the parameters that we want to make it more close to the real object.
想看一下孔洞是吗？
哦，我知道它的意思。等一下。Okay, I see another question. Is it possible to give straight vector to host extrusion? Okay, I guess you mean when we're doing the hole digging, you mean whether we can define the direction of this holes, right? Not just extracting the primitives based on the based on the real industrial mesh. Currently, we are simulating the elements on the object that is that we need to do fitting. The fitting is a reference for us to create a cylinder like what we have done in the software. And if you want to make those cylinders straight to the model or just straight to the coordinate system, you can give the constraints on the shape. Just like when we are creating the model, like the cylinder, we can do the constraints when we are processing the 2D sketch. That is not finished in the extraction. Like when we are doing the 2D sketch, you will see some constraints, like the vertical, like perpendicular, or parallel, or something like, just like this. So we can do this step. We welcome more comments about this reverse engineering and the scanning. If you have questions about the scanning, we can also give you the real-time answer.
需要点这个吗？
Okay, we can also do the comparison and to set the tolerance. After we have finished the reverse engineering, we can make the deviation analysis. Like we are setting the tolerance to 0.5 millimeters. So you can see here the largest part of this industrial components are green, which means it's within the tolerance. And as for the joint section, you can see there are some red or even no color data. That's because this industrial part was joint with the manufacturing, like the welding. So we have some excessive materials on that stuff. So we just need to go back to the clean and precise original hardware structure of this industrial part, ignoring the materials that is actually happening on this industrial part. Okay, I noticed other questions. Can I make holes with the pattern feature?
他想找一些特征。
I don't like CAD comparison. Let me see. I'm not sure the question that you are proposing. Like you don't want the comparison within this software using the analysis, or just like pattern feature? I have no idea of your question.
他不喜欢这个 CAD 的对比是。
So I'm trying to understand your question, because you mean you want to dig the holes with the actual components or other things? Is any option for change the sketch plane section? You mean changing the directions
Yeah.
of this reference plane? The sketch plane was created based on the actual scanning object. So if you want to change the direction, I'm afraid that you cannot change it, because when the model is finishing the alignment, the direction is defined.
Oh, you can see.
Or if you want let me see. 不知道它 sketch plane 不是那个意思，是那个意思。How can we do the same process on assembly product? So this live stream is showing a reverse engineering based on the product that is also assembly, because it is welded by the both parts. So for the assembly products, you need to do the reverse engineering separately, and then to combine them based on the CAD file. And you can do the simulation of the assembly and the other CAD files.
给它演示一下草图吧。
演示啥图？
草图的。
你把那个实体模型给它关掉，然后把那个草图给它关掉。QS 的人过来解答一下我的。QS 的人过来解答。
现在吗？
没有。
我之前有留线告诉他了，我已经跟他说了。
Do you have any questions? We welcome more comments. OK， 可以了。没事，我们差不多站起来吧。OK， 那。
OK。
Yes, we have finished today's live stream and go through the whole process, including the scanning, the conversion from the mesh model and the 3D CAD file. And this will be a very efficient way to from scan to CAD. We only used 1 hour to go through the whole process. So if you have any questions about the reverse engineering and the scanning, welcome to email us or contact our other colleague, like our sales or other the company company members. And today's live stream will finish within the 5 minutes. So if you have any questions, please text in the chatting box. And if you are having long questions about or you want to repeat to review this live stream, we will give you the recording link after this live stream. 进来了。Okay, so this will be today's live stream. Thanks for all your attention and have a nice day.